So for our documentation video today here, we're going to be pulsing at 522 Hertz, 85% duty cycle. We are going to be jacking this thing up to the maximum voltage of 31 to 32 volts just to get maximum production out of these things to measure bubbles to prove a point here. Our amperage is still going to be about 1 amp. It's going to be just a little over 1 amp. My diodes will probably get pretty warm. Let's hope they do not blow up here. I may even clear out all this mess so you can see that there's no hidden wires or, you know, double-sided mirrors or smoke or anything like that coming out. Hope there's no smoke. You know, to my apparatus here, just to know that, hey, look, we got a power supply. This is my relay control board. The only thing this really does is turn the cells on and off and flip the primary polarity. These are no longer used. That's part of the matrix switchboard, which is all these control wires here. Majority of them are not used because they were for those here. Got my PWM here. Probe connected to the output of the PWM. It's shared on that output. My driver board, you've seen this before in my previous videos. My standard snubber configuration as documented. All we have essentially in this configuration here is our primary coil in a bifilar mode. This is the center tap of that bifilar mode. This is the power coming from the 30 volt power supply and MOSFET delivering the square wave signal. The secondaries here, we have two coils. That's coil 1. This is coil 2, indicated with these pieces of tape here. We have the secondary in a bifilar configuration, whereas these two here, this is just a bridge inside of this thing. Jumper is the purple to the gray. That is all. There's nothing else. I'll pry this thing open later. You guys have seen the inside of this thing before. It's nothing special. These are my two diode locations. So on each side of this secondary, we have these connections here, one for the positive end and one for the negative end. This being the positive end here, we have this diode, this 2 amp diode. It's part of the VIC circuit. And then on the negative side over here, we just have it jumpered. There is no diode in there. It is just a wire jumping from one to the other. Here are inductors where this guy right here, this brown, connects to here. And since we have a jumper, this goes directly to the cell output, which is this green one right here. This diode connection here, this guy specifically, connects to this right here, these two connections here. So we have the inductor, the balancing inductor, connected here just after the diode. And then that feeds into that orange positive connection to the cells. Alright, so yeah, from that there, we got that red Cat 6 cable coming right here, splitting off to the amp meter, returning with a 1 amp diode into the cell, coming out of the other end of the diode, going back to the VIC through that shielded red Cat 6 cable, though, the orange and green connection as you saw previously, though. I did clean out this whole area just so you can see these bits. If I can get on the light here, this is the setup, voltmeter and oscilloscope rather, hooked up to the positive and negative terminals, first in, last out, and the amp meter just hooked up to the positive input in series to measure the amperage appropriately. And just for reference, this is a concrete brick wall behind this, so there's nothing behind here, you know, going into a wall or, you know, a secret gas pump somewhere or other nonsense some people are claiming that I potentially might have. This is just the cells output through that little tube here, over here, coming back, bam, and out to the bubbler. In case you really want to see back there, you know, I'm talking brick wall here. There ain't nothing but this setup. Alright everybody, here it is, the official gas production test. Here I have my entire apparatus, as you see. We've got the variable DC power supply, our 12 volt power supply for the PWM right behind here. Here's our PWM. Here's our driver polarity and on switch. We have the driver board slash snubber right here. Of course, our VIC custom wound transformer. And the output of that being this red Cat 6 shielded wire over here. The orange one, of course, to the amp meter going into the positive end of the cell with 1 amp diode, out with 1 amp diode, returning back to the green over there to the VIC. We have all the cells here in series. We're going to start this timer, but we're going to get this thing up to full speed first. Let me take care of these wires here and clean this up one sec. Alright, decided to clean up some of these wires here just so there's no confusion about what's going to what. These are just power cables to my power supplies and my oscilloscope up here. Shorten these wires here so you can definitely see, hopefully from this vantage point, the diode, the one puny 1 amp diode going into my cell. And these voltmeter connections from first in, last out. Also the negative return going back to the VIC also has this puny 1 amp diode, as you hopefully see right there from that vantage point. Okay, we are going to turn this thing on and begin production. We're going to get this thing up to full speed, and I'm going to be starting this timer, and then as quickly as I can put this cap onto this water bottle to see how much or in what time span that this 500 milliliter bottle is filled up. So we're going to give the clock an advantage by starting the clock first and then missing out on whatever time it takes me to secure this cap on here. So we're going to get a couple of seconds head start on the clock. So I'm going to be behind on gas production. Let's put some voltage in this thing. We need to reverse this here so we get the proper waveform here during the pulse on time. Beautiful equal opposite polarity pulses being generated. We've got 835 milliamps traveling through the cell right now. As hopefully as you can see in this video from that vantage point. It might be kind of difficult. I'm going to prop this up for that vantage point. Pretty sure you can see the voltmeter from there. All right. You can see we have some gas production starting here. It's going to take just another minute to get it up to full speed. Okay, we are currently up to 114 volts at the cell. We've got 940 milliamps at the cell, 6 amps total power input at 28.5 volts. We are now going to max this thing out, and that will take it up to 32 volts. I now have 1.1 amps at the cell, 7.3 amps consumed, a little bit higher than normal, but we have a ton of gas production here. I'm going to get this ready, and on the count of 3, 1, 2, 3. And we're off. We are pushing 1.1 amps into those diodes, so they're probably warming up, but they hopefully are going to hold. 2522 hertz, 85% duty cycle. We're at 121, and this bottle is just about full. There's just the tiniest bit of water left in it. And there we are. Pause. So that, let's say it was 1:42. All right, we're going to document our work here. One moment. My diodes, checking them here, are relatively cool. They are not hot at all. My cells, cool to the touch. Wires, still cool to the touch. Moving on to test number 2. Let's get this puppy cooking again. We're going to bring it up to full speed here, full voltage. There we are, got 118 volts at the cell. Frequency going up to now 550. We're at 570 hertz and 117.9 volts. We're at 31.98. Currently 7.24 amps consumed. We're on test number 2. Looks like we're up to maximum speed here. We're going to reset. And maybe in the video we can determine how much time I'm spending on this here. And also be note that, a 500 milliliter full bottle is not all the way up to the tippy top. It's got some space there at the top. So to be considered. Are we ready? 1, 2, 3. Alright, you're secured. It's already 8 seconds in, but we got that pretty close, I believe. Go, baby, go. 1.126 amps at the cell. Minute in, looks like we're over half full. There. We're gonna call it now. All right. $137.7. Let's check these diodes. Diodes are warm. They are not hot. Diode is just a little warm, not hot. Cables, cool to the touch. Cells, cool to the touch. Let's check some temperatures over here. Remains cool. Our MOSFET heatsink is cool. Our resistor is cool. This is a cold system here. Probably the only thing generating any amount of heat whatsoever, which this thing's also cool to the touch, would be my DC power supply. And I think this thing will do 10 amps, maybe more. Let me make sure you guys see that. 1 minute 37 seconds. 500 milliliters of HHO at 1 amp consumed at the cells. Test 3. Let's do this one more time. Let's get you back up to speed. 570 hertz, 85% duty cycle. At 29 volts, we're consuming 967 milliamps at the cell. We do have 112 volts spanned across those cells. We're going to reset this. We're going to crank up to our maximum value here. 32 volts input. 7.29 amps. Let's see if it wants to determine. 7.27 amps. Okay. I think we are at full speed here. Let's get this ready. We are recording. This is test number 3. Bubbling, bubbling. 3, 2, 1. Currently at 7.25 amps. We got 3205. Good. Test 3, we'll see if we can beat 137 here. Get as close to a minute and a half as possible. So, per my previous video where I measured estimated 1.5 minutes to create 500 milliliters of HHO, was not far off. We were off by just a few seconds on that. So I believe these are a lot more scrupulous, more specified results here. So you can take these results and come to your own conclusions. Seconds. You are full. All right. $137 again. $137. So there we go. The 500 milliliter test is complete. We have 3 results. Minute 42, a minute 37, and another minute 37. So it's safe to say that we're just over 3 minutes per liter of HHO gas. So we're going to do some calculations here. We're going to give the exact numbers to know how many amps I'm utilizing at the cell to create 1 liter of HHO gas. Thanks for watching.
This is Stan's Revenge.